Hello everyone, this is the first video in the dynamic programming playlist. So we'll first understand what dynamic programming is. So at times when we are solving recursive questions, we get to know that there are sub problems that are getting solved again and again, right? So dynamic programming is an optimization technique such that we save the solution to the sub problem and use that later so that we don't calculate it again and again. We'll take an example for this. You already might be familiar with Fibonacci series, right? Now, what Fibonacci series is? Let's see. Fibonacci series is for f nth term you need to calculate. You need to add n minus 1th term and n minus second term, right? Okay. Now, uh, what are the base conditions? We know that f of 0 is equals to 0 and f of 1 is equals to 1. Okay. So let's write recursive code of this. I've made a class in here. This is a Java class. I've made a class in here. And this is a recursive function. Let's complete this function. It takes an input n and gives an output of integer. So I'm going to say if n is equal 0 or n is equal 1. That is the base condition. If it is 0 or it is 1, it should return n. Now why? I'm saying that if it is 0, return 0. If it is 1, return 1. Then I'll be saying my value is equals to fibo of rec of n minus 1 plus rec of n minus 2, and I'm going to return this value. So what I'm doing, I'm saying that if it is 0 or if it is 1, return 0 or 1, whatever it is. Else calculate this, else add the previous value or the previous to previous value and then return that particular value. Now let's see when this will execute, what will happen. So what we'll be doing is, let's say n is equals to 5. Let's take an example and let's see what happens. Okay. So initially when I'll be calling for n is equals to 5, the computer will say, okay, n is equals to 5 in here. But to solve for n is equals to 5, we need to go to n is equals to 4 and n is equals to 3. But first it will solve for n is equals to 4. So it will call for n is equals to 4. Okay. This is how the code will execute. Okay. Then this 4 will call for n is equals to 3. Now this 3 will call for n is equals to 2. This 2 will call for n is equals to 1. And we know the value of 1. So it will be returned. The value of 1 will be 1, right? Then 2 will also call 0. And then this value will be returned. This value is 0. So 1 plus 0 is 1. Now we know the value of this part, so it will be returned to 3. But 3 will also call 1, which will be returned since we know the value of 1 already. So this will return 1. So 3 will be 2. This 2 will be returned to 4. Now 4 will solve for 2 again, right? It will call 1 and it will call 0. 0 will return 0. 1 will return 1, right? And 2 will add up these 0 and 1, and the answer for 2 will be 1, and it will return that to 4. Now this 2 plus this 1 is equals to 3, which will be returned to 5. Now from 5 we will call for 3, the right side, this part, right, this part. Then 3 will call for 2, 2 will call for 1, 1 will call for 0. This will be returned, this will be returned, the value of 1 on 2 will be 1. This will be returned to 3. 3 will call for 1 and 1 will return value of 1. So 1 plus 1 is 2 and this 2 will be returned to 5. So 3 plus 2 is equals to 5. So we got to know that the value of Fibonacci of 5 is 5. So this is how it is executing. Now what will be the time complexity of this? So the time complexity of this is 2 to the power n. Okay. Now what is the problem with this, right? Why do we need to optimize this? So the problem with this is, you can see that this subtree is getting calculated in here and also getting calculated in here. That means it is getting calculated 2 times. Then again, this particular subtree is getting calculated in here. It is getting calculated in here, as well as it is getting calculated in here. That means it is getting calculated 3 times. Now, why would I do this? Why would I again and again solve for 2, right? So a good approach would be that if I have already solved for these things, then I'll simply return the value. So now what will I do? Let's optimize this. What will I say? I'll take a hash map. I'll say a map, integer to integer. Okay, and I'll say it cache. I'll say new hash map. Okay. So what this does is, it will store the value of integer of n to its answer, whatever the answer of the n would be. So the base condition would remain the same. I'll say n is, if n is equals to 0 or n is equals to 1, return n. Now I'll be saying, what if I've already calculated this value? So if I've already calculated this value, this particular value would already be in my cache. So I'll say if cache dot contains key. So this contains key is a method in Java that checks whether this particular value is present in cache or not. So if it is present, I'm going to return cache dot get n. Okay. If this particular value, if this particular value has not been solved, what I will be doing, I'll be saying int. Now I'm going to solve it. I'm going to say bottom up. Bottom up. I'm going to say n minus 1 plus bottom up n minus 2, and I'm going to say, I'll also have to put this in cache, right? I'll also have to save this, so I'm going to say cache dot put n comma this particular value, and then I'm going to return this value. So let's see how this code will get executed. So firstly, what I'll be doing is I'll be having a map as well. Okay, so this is my map in here. Okay, this is my cache, right? Whenever I'll be saving anything, I'll be writing in here. Okay, so again, let's execute for n is equals to 5. So initially n is equals to 5. It is going to call for my 4. 4 is going to call for 3. 3 is going to call for 2. 2 is going to call for 1. And now 1 will return the value 1. It will call for left side. Left side will return value of 0. 1 plus 0 is 1. This will be returned to 3. Now 3 will call for 1 again. Okay, I know the solution answer for 1, that is 1. It will return in here, right? So 1 plus 1 is 2. Okay, this 2 will be returned to 4. Now 4 will call for 2, right? Since I've already calculated this 2, whenever I'm calculating anything, I'm going to store it in cache, right? Since I'm storing it in cache, look, I've calculated for n, right? And I'm storing it in my cache. So as 2 will be already 2 will already be stored in cache. So 2 stored 2 is hashed to 1. Similarly, 3 is hashed to 2, right? So when 4 will be calling to 3, my compiler will first check that is my 3 stored in this particular, is my 2 or 2, it is it stored in cache already? Since it is stored in cache, it will directly send the answer without calculating. It will say 1, right? So 2 plus 1 is 3, which will be returned to 5. 5 will call for 3. Is my 3 saved in cache? Yes, so it will directly be returned as 2. So 3 plus 5 is equals to 2. So this is the importance of cache. Now, what is the time complexity? Earlier, the time complexity was 2 to the power n. Now the time complexity is n, O of n. Okay. Now let's see that, okay, so these are all recursive stages. Okay. Now let's see what happens when we do a bottom up of this, right? Sorry, when we do a top down. This is bottom up. Now let's see what happens when we do a top down. So whenever we want to do a top down, we take an array called, let's say I'm going to call it dp is equals to new integer n plus 1. I'm going to say dp of 0 is equals to 0, dp of 1 is equals to 1. And then I'm going to start a loop from 2 for integer I is equals to 2, I is smaller than equal to n, I plus plus, and then dp of I is equals to dp of I minus 1 plus dp of I minus 2. And at the end, I'm going to return dp of n. Okay, now what is happening in this particular question? Let's visualize what is happening in here. We want to calculate for dp of 5. So this is my dynamic dp array. Okay, 0 index, 1 index, 2 index, 3 index, 4th index, and 5th index. Now we know that the value of 0 is 0. We know that the value of 1 is 1. Now when we want to calculate this particular value, I'll add this value and I'm going to add this particular value, right? So it becomes 1. Now when I want this particular value, I'll similarly add this value and I'm going to add this value. So this will become 2. When I want to calculate this value, I'm going to add this and this. So this will become 3. And similarly, when I want to calculate this, I'm going to add this value and this value. So it is going to become 5. Now the question is, what is the importance of Fibonacci series, right? Why are we so focused on a Fibonacci series? So let's solve an example. Let's get an example, right? Just keep in mind what we have learned in here, right? So there's a question. So question is that we have been given n number of stairs, right? For this example, I'm going to take 5 number of stairs. Okay. So we've been asked that these are stairs 0, 1, 2, 3, 4, and 5. So I've been told that I'm initially at the 0th stair. Okay, and I want to reach to the this particular stair, fifth stair, nth stair. So my question is that I can only jump to one stair next or next to next. That is, I can jump to from I can jump to I plus 1 or I can jump to I plus 2. Okay, so the question is that uh, how many ways are there such that I could reach this particular stair? Okay, this question was asked in Amazon and is a medium level question. And let's see how using Fibonacci series we can solve this. So when I'm at 0, what is the number of way to be at 0? And the answer is 1, right? We can be at 0 stair because we already are at the 0th stair, right? It's not that there is 0 way to reach this particular stair. There is one way, that we are already there. Now what is the way to reach the first stair? We can only reach it from 0, right? I can only reach this stair from 0, that is 1. That's why there is only one way to reach the stair. Now what are the ways to reach second stair? I can either reach from here or I can either reach from here. So I'm going to add these two, that number of ways from 0 and number of ways from 1. So the answer is 2. Again, when I'm at here, I'm going to say, okay, number of ways that I can reach to this stair and number of ways that I can reach to this stair. So I'm going to add those two, 2 plus 1, 3. Again, when I'm at here, number of ways to reach at here and number of ways to reach at here. That is 3 plus 2 is 5. And again, when I'm at 5, I'm going to say number of ways to reach at 4th stair and number of ways to reach at 3rd stair. So the answer is 8. Now the question is, what did change? Because we know that the function is same. Fn is equals to fn minus 1 plus fn minus 2, right? This is the same. The only thing that changed is the representation. Here I was talking about Fibonacci series. That means my array was storing that what is the meaning of this particular index. What is the meaning? The meaning of this particular index is that dynamic programming, this particular array is storing this the Fibonacci series, the first Fibonacci series, the first Fibonacci number. But in here, this particular thing means that my dp array will store how many ways are there to reach to this particular stair. That is the difference. And another difference is the base case. Here we can see the base case for 0 is 0 and 1 is 1. Here we can see the base case for 0 is 1 and 1 is 1, right? So I'm going to say for 0 is equals to f of 1 is equals to 1. So let's try to solve this question. I'm going to solve this in top down only. Okay, if you want to solve it, if you want to change that, if you can change a small thing and convert Fibonacci series to this, I'll only convert the base condition. I'll say for 0 is equals to 1, and this is it. This is it. This is solved. And that's it for the first video. Thank you.